In this video, we are going to continue with the more concept. Now, this part will look at the molar concentration of solutions and we'll also look at the dilution. Now, first let's begin by we define the concentration. So concentration can be defined as the number of moles of solute per volume of solution in cubic decimeters. So what this means is, in order for us to have a solution, we need to have the solute, then plus the solvent, then this will give us a solution. Now, a solute is a substance that dissolves in a solvent, while a solvent is a substance that dissolves a solute. So that dissolves a solute. So for example, if we have a solution of water and salt, so the salt is known as a solute because a salt will dissolve in water, while water will be known as a solvent, since water will dissolve our salt, which is our solute. Now from there, concentration tells us how much of salt or the number of moles of salt is in a given volume of solution. So for example, as concentration may be higher or concentration may be low. So let's look at if we have a high concentration, what it means by a high concentration. So for a concentration to be high, the first step you need to know is there are more solutes compared to solvent. So there is less solvent, more solute. So whenever the solutes, the number of moles are greater of solutes are greater than the number of moles of a solvent, we have a concentrated solution. Now for a low concentration is just the opposite. So for low concentration here, we can now see that we have less solutes. So we have less solutes, while for solvent we have more solvent. So where if you have a lower concentration, we are looking at assuming you have maybe just a teaspoon of salt and you put that into maybe 5 liters of water. So you can see that the number of moles of the solid of salt is far much less than the number of moles of water. So there we are expecting to have a lower concentration. Let's maybe have a diagram. So one will have a higher concentration, then the other one will have a lower concentration. But we are going to assume these two have the same volume. Let's say we have the same volume, which is 10 cubic centimeters and also 10 cubic centimeters. Now there is water. Then we are going to say that the first part here we have maybe particles, just these particles. Then here we have more particles as we can see. So we can tell from the diagram that here these are just the salty particles. Then also here we have the salt particles. Now from diagram A, we can see that the particles of salt are less compared to diagram B. So you can see that diagram B here there is high concentration. There is high concentration because we have many number of moles of salt particles. So then here we have low concentration. So in summary, we can say for a concentration to be high, the particles of the solutes must be in a greater in a greater number compared to a low concentration. Now let's look at the formula for concentration. So now concentration can be calculated by an equation. So concentration is equal to number of moles of solute divided by the volume of the solution. Okay, now from there, the concentration, the symbol for concentration depends with the book. So is C, the number of moles, small letter n, over the volume, we just have our V. Now we can rearrange this formula. We can also use this formula to find the number of moles given concentration and volume. Also we can find the volume given concentration and number of moles. So where concentration here, the concentration should be measured in mole per cubic decimeters. Then for the n, number of moles, we know that number of moles should just be measured in mole. Then for the volume, make sure that the volume should be in cubic decimeters. So in a case where you are given volume in centimeter cubed, you need to convert from centimeter to decimeter cubed. Now from there, let's look at the relationship between concentration and number of moles. So the first one, concentration is directly proportional to number of moles. So what this means is if we increase the number of moles of the solute, then we are expecting the concentration of a solution to go up. So if one factor increases and the other factor increases, we are dealing with what we call a direct proportion. So therefore, concentration is directly proportional to number of moles. Now, what of so concentration and volume? So concentration and volume is inversely proportional. So what this means that if the concentration increases, the volume will go down, or if we increase the volume, we are expecting the concentration to go down. So an inversely proportional relationship describes that if one factor increases, the other factor decreases. Okay, let's maybe look at this point in terms of mathematically. So let's say we have, now for this one, we are going to assume that the number of moles stays the same. So let's say we have the number of moles of, let's say 50 moles. Now, we are going to have the first volume. We are going to say the first volume is 10 cubic decimeters. Then if this is our volume 1, then the second, which is our volume 2, we just say 25 cubic centimeters. So we are going to find the concentration for each. Now, provided the number of moles is constant. So what we are just changing here, we are only changing the volume. So let's look at the first one. So you can say concentration is equal to number of moles over volume. So concentration is equal to the number of moles is 50 over our volume. The first volume here is 10. So you can see that 10 into 50 is 5 mole per cubic decimeters. So that is the first concentration. Now let's say if we have the second concentration, so concentration is equal to number of moles over volume. So concentration, we are saying the number of moles will just stay the same, so we just use the 50, but now the volume has increased from 10 to 25. So 25 into 50 is 2 moles per cubic decimeter. So what this means is, the first part, what this means is per 1 decimeter cubic there is 5 moles of solute. Then for the second one, per 1 decimeter cubic there are 2 moles. So we can see that we can see that the first concentration when the volume concentration when the volume was 10, the concentration was 5 moles per cubic decimeters. But when the volume now increases from 10 to 25, then we can see that the concentration reduced to 2. So we can see that as the volume was increasing, the concentration is decreasing. So that is what it means by inversely proportional. So therefore, concentration is inversely proportional to volume. Okay, now let's look at the first example. Okay, so the first example is 2 grams of sodium hydroxide are dissolved in 50 cubic centimeters of a solvent. What is the molar concentration of the solution? Okay, so here we can see that we have a beaker. So we have a beaker. Then in this beaker we have water, and we have been given the volume of water shouldn't be 50 but should be 500. Now the volume of water is 500 cubic centimeters. Then now the question is, if we are to dissolve 2 grams, so if we are to dissolve 2 grams of sodium hydroxide here, so if we are to dissolve 2 grams of sodium hydroxide, what concentration will it give us? So that is what the question is. So let's now go back to our formula. So we know that the concentration is equal to number of moles over volume. So from there we can see that the volume, we have it. So the only thing to do here, we need to find the number of moles. So what is 2 grams of sodium hydroxide in terms of number of moles? So let's find the number of moles when mass is given. So number of moles when mass is given, number of moles is equal to mass over molar mass. So here we are going to find what we call relative formula mass, since we are dealing with an ionic bond. So let's find the mixture. So from the sodium hydroxide, we can see that we have 1 atom of sodium, so times 1, plus 1 atom of oxygen times 1, plus 1 atom of hydrogen. So the mass number for sodium we'll use with 23 times 1 plus 16 times 1 plus 1 times 1. 23 times 1 is 23 plus 16 times 1 is 16 plus 1 times 1 is 1. So 23 plus 16, 39 plus 1, we have 40. So therefore molar mass is equal to 40 grams per mole. So we have the molar mass. So now after finding the molar mass, now we can proceed to finding the number of moles. Okay, so the mass is given 2 grams divided by the molar mass is 40 grams per mole. So we can cancel this. So number of moles is equal to 2 divided by 40. So we have 0.05. So these now are the number of moles. So whenever you have been given mass and want to find the number of moles, so this is the formula to use. So now we can go back. So you can say now concentration is equal to the number of moles is given 0.05 moles divided by the volume. So from there we can see that the volume is 500 cubic. Now remember we say the volume should be in decimeter cubed. So we can see that we say the 1 cubic decimeters is equal to 1000 cubic centimeters. So if we are converting from decimeter to centimeter, you multiply by 1,000. Then from centimeter to decimeter, you divide by 1,000. So since we are converting from centimeter to decimeter, we are going to divide. So 500 centimeter, 500 divided by 1,000, you are going to get 0.5. So 0.5 decimeter cubic. So centimeter, concentration now is equal to, so 0.05 divided by 0.5. Our answer is 0.1 moles, mean 1 mole per decimeter cubic. Okay, let's have another example. Okay, now for example 2, it's different. So now here, calculate the number of grams. So here we are calculating mass of beryllium chloride that are needed to make 125 cubic centimeter of a 0.05 mole per cubic decimeter. So here we are looking for mass. So first, number one, let's look at the data that we have. So from the data, we can see that we have the volume is given and the concentration is given. So this can help us to find the number of moles. Like we said, concentration is equal to number of moles over volume. So if we divide by 1 and cross multiply 1 times N, we can see that for us to find the number of moles, we need to multiply concentration times the volume. So after finding the number of moles, we can now go back to the formula where mass is. So we can see now number of moles is equal to mass over molar mass. So over 1, you can see that in order, if you want to find mass is found by multiplying number of moles times the molecular. So molecular mass. So in our case, formula mass, since it's an ionic compound. So the first part, this formula will help us to find the number of moles. Then we can now substitute the number of moles into the second formula so that we are able to find the number. So now let's find the number of moles by the first part. So we can see that number of moles is equal to concentration we have been given is 0.05 moles per decimeter. So per decimeter times now the volume is given 125. Remember, the volume is in cubic, so we divide by 1,000 in order to convert into cubic, so into decimeter cubic. So 0.125. So 0.125 decimeter cubic. So that this and this now can cancel. So 0.05 times 0.125, we have 0.00625 moles. So these are the number of moles of beryllium chloride. So now after finding the number of moles, now we can now go back to this formula. Mass is equal to, the number of moles is 0.00625. Now times, we need to find the relative formula mass for beryllium chloride. So we can now say Mr. is equal to, so from beryllium chloride, we can see that there is 1 atom of beryllium, so Be times 1. Then also 2 atoms of chlorine, so Cl times 2. Beryllium has mass number of 9 times 1 plus 35.5 times 1, times 2. So 9 times 1 is 9. 35.5 times 2 is 71. 71 plus 9 is 80. So therefore, relative formula mass is equal to 80 grams per mole. So here we can now put our 80 grams per mole. So this mole and this cancels. So we need to multiply now 0.00625 times 80. So our answer is 0.5 grams. So this is our final answer. Okay, now we can move on to dilution. Now dilution, we know what dilution is. There are so many stuffs that we dilute in our daily life. Like when we have a concentrated juice, we dilute. So we dilute a highly concentrated solution, and we know that whenever we are diluting a solution, it means we are trying to reduce the concentration. And remember, we said concentration is inversely proportional to volume. So for us to reduce the concentration, we need to increase the volume. So that is what happens. So whenever we are adding water to a highly concentrated solution, we are decreasing the concentration but increasing the volume. So therefore, dilution simply means to add more solvent without adding more solute. Now, there is one note that you need to know. The number of moles before dilution of solute must be equal to the number of moles after dilution. Even so, what you are saying is if we have 2 moles of salt, then we make a solution and that solution is highly concentrated. Even after we add a certain amount of water, we're still going to have the same 2 moles of salt. So therefore, what you're saying is before and after dilution, the number of moles of the solute does not change. So what changes is just the concentration and the volume. So that is what changes. So therefore, take note, the number of moles before and after dilution of the solute, take note of the solute, does not change. So what we are saying now is moles of solutes before dilutions, and we'll call before dilution, we'll just call it N initial, where the N represents the number of moles is equal to. Then we are saying even after dilution, the number of moles must be equal to, so is equal to moles of solutes after dilution. Now our after dilution, we just equate this one as N final. Okay, so depends, you can use maybe numbers. So if you can say 1 represents the initial, then 2 will represent the final. So here we are using now the initial. So now let's go back to the formula for concentration. So we said concentration is equal to number of moles over volume. The number of moles is equal to concentration multiplied by volume. So we can see that here we have number of moles initial before dilution must be equal to number of moles after dilution, which is N final. So here where there is N, we are going to substitute with this part because we know that number of moles is equal to concentration times V. So here we are going to have C times V is equal to C times V. So where there is N, we have substituted with this part here. So now for us to differentiate before dilution, here we can just put I, then here I, so to indicate the initial or this before dilution. Then here we can now put after, so the after can be indicated by final. So this is an equation that we can use whenever we are dealing with problems of dilution. Now let's have a particular problem. Okay, so the first example is how much water must be added to 20 cubic centimeters of 0.2 molarity hydrochloric solution to produce a solution that has a concentration of 0.16. So here we want to find the amount, the volume of water that we can add. So meaning here we have the first concentration, the concentration before dilution was 0.2, then the concentration after, so we can now say initial and final. So from this we can see that the initial concentration is 0.2. Then the final concentration was 0.16. So we can see that the concentration reduced. So we are expecting the volume to increase. Now the volume, the initial volume was 20 cubic centimeters, but we don't know the volume after a certain amount of water was added. So we can just put X here. So now what we are going to do here is, first we have the initial volume, so we are going to find the final volume. Then from the final volume we'll be able to see the amount of water which was added. So now let's go back to our formula. So our formula, we said concentration, initial concentration times the initial volume is equal to final concentration times the final volume. So initial concentration is 0.2 times the initial volume is 20 cubic centimeters. And if you have a problem like this one, dilution, if the question is not specified in terms of volume, no need of converting, you can just use the way they are. So you are not converting, you are not going to convert 20 cubic centimeters into decimeter cubic. We can just calculate it using them just like this. So here now concentration, the final concentration is 0.16, right, times the final volume we don't know. So here we can see that we can multiply 0.2 times 20, we have 4 molarity cubic centimeters is equal to, then 0.16 m times Vf, we have 0.16 m Vf. So we can divide by 0.16 m over 0.16 m. So we can see that now the final volume is, we are going to divide 0.16 into 4 is 25 cubic centimeters. So you can see that now after a certain amount of water was added, the volume rose from 20 cubic centimeters to 25. So 25 is our final volume. Now here the question is how much water. So I just want to know how much was added. So we can see that from 20 to 25, the amount of water that was added was just 5. That is the volume of water that we now was added. So we can say now, therefore, the volume of water added was, so we can say final volume minus initial volume, which is 25 cubic centimeters minus 20 cubic centimeters. So 25 minus 20, we get 5 cubic centimeters. So this was the volume of water which was added. So you need to be careful with how the question is being asked. Now if the question was find the final volume of the after dilution, this is our answer. Now the question was how much water. So we just want to know the volume of water that was added to 20 cubic centimeters. So we find to be 5 cubic centimeters. Okay, now let's look at the last example. If you add 25 cubic centimeters of water to 125 cubic centimeters of a 0.15 molar sodium hydroxide solution, so what will the concentration of the diluted solution be? So let's say we have the initial. So the initial is before dilution and the final after dilution. So now we need to be careful here. So the volume of this solution before dilution is 125 because we are looking at if you add. So before this 25 cubic centimeters what was added, so the volume was 125 cubic centimeters. Then now after we added 125, so the volume now became 150, because where the 150 is coming from, we had a volume of 125 cubic centimeters plus another volume of 25 cubic centimeters now is added. So we are diluting, we are adding water to this 125 cubic centimeters of solution. So we have now the volume rose from 125 cubic centimeter to 150. So you can see that the volume now became 150. Now before the 25 cubic centimeters was added, the concentration was 0.15. So now the question is, we want to know the final concentration. So since the volume increased, the concentration must be reduced. So let's go back to our formula. So our formula is the initial concentration times initial volume is equal to final concentration multiplied by final volume. So initial concentration is 0.15 multiplied by initial volume is 125 cubed centimeters. Final concentration is what we are looking for, times final volume is 150 cubic centimeters. So we can now multiply 0.15 times 125. So here we are going to get 18.75 molarity cubic centimeters. Then 150 cubic centimeters times CF, we get 150 cubic centimeters. Here we divide by a 150. Even here we divide by a 150. So we can cancel this. We have final concentration is equal to, this will give us 0.125 moles now of sodium hydroxide. So this is our final answer. That's it for this video. Please subscribe and share. Thanks for watching.